So what we did is create a detection model that is trained on every single symbol, button, dashboard lights to simply detect them. Once it detects them, cuts them out, and then goes to a second model that takes every single cut out and passes it through a classification model. Dividing the detection into stages worked a lot better performance-wise.
Every driver has this experience. You see a indicator light or a warning light, and you think, I don't really know what that means. Or every time you get in your vehicle, there's that one button, and you look at it and you think, someday I'm going to look up what that button means, but then maybe you never do. Well, now, some people, they have an application where they can simply point their smartphone at that mysterious light or button, and they can instantly get more information about that feature. This helps them better understand their vehicle and get to know all of the cool technology that may be included. And today we are going to be diving into that application called Audi Reader, which was developed by a team at Ogilvy Spain and Audi. And we're going to take a peek at the development process of the custom computer vision models that help power that application. My name is Patrick Descher. I am from RoboFlow, and I am very happy to be joined by Lorenzo Spadoni from Ogilvy Spain, who led the project to develop this application. First, Lorenzo, thank you very much for joining this session. Would you please like to say hi and introduce yourself to everybody?
Hi, well. Thank you very much for having me. This is great to have a chat with you, and I hope the session will be very interesting because I think what we worked was a really cool project. I work at Ogilvy Spain, and I'm an innovation technology partner. So I work on the cutting edge technologies, and what I do is merge the creativity with the kind of latest technology to bring the ideas to life. What else? I mean, I work on several clients. Audi is one of them, and Audi brought this challenge to us.
Beautiful. Thank you. Well, so speaking of that, I wanted to hear first about the motivation behind developing this application. So could you tell us a little bit about that?
So I think this is one of those insights that kind of drive a whole idea. Because if you imagine Audi, for example, prints 1.9 million manuals, and actually only 30% of them read them. So we have a car that is highly technological, and most of the people don't know what anything does. A lot of buttons, a lot of functionality go unseen. So we wanted to find a more interesting way of getting people to discover their car. And the mobile is something that we hold in our hand every day. We go through it for finding all sorts of information, and it made sense to enable this through the mobile. And that's where we thought, okay, how could we use the mobile and use the camera to actually get an idea of what the functions are? And so this is where the whole conversation started. Is it even possible?
You know, personally speaking, I have opened up the user manual in my car and my eyeballs have moved over the text, but I don't know if I actually read anything in there. Do I count as the 30% or the 70%?
It's so dense. I mean,
Yeah.
even like if you use the actual text, it's so dense of information. There's so many caveats everywhere. So all you wanted to know is, can I still drive with this light on? Am I going to crash somewhere, or my brakes are gonna fail and suddenly, it's the simplicity sometimes of knowing that you can do a simple action to make your life easier.
Well, so speaking of making people's lives easier, we have a video that was pre-recorded, and it's a demonstration of the Audi Reader application. I'm going to hit play on that video. We don't have sound that will come through, so I'm hoping, Lorenzo, that you can
Mm.
kind of narrate us
Top
through the
of it.
process. Yeah.
I will
All right.
top of it.
Great.
So, so first of all, the Audi Reader is part of an application, an Audi application called My Audi and Me. So this is the app that people have for their car. And so first of all, through the My Audi and Me, they can open the functionality where they can use Audi Reader, and all they have to do is, and as a user, all you have to do, you have to point it at the buttons that you want to find out what it does, and the system will detect the buttons, the icons, the dashboard lights, and bring them up with a bounding box in a way that you can interact, and you can tap on it, and you can find out more information. But it doesn't stop there. Also, what it does, if there is a light that is possibly something serious, you can also call assistance or book a service directly. It's amazing because you can message the assistant straight from the application, and I think it makes sense that, the idea of right, if something is wrong with my braking system, I can book an appointment, I can find out where it is, I can in the calendar I can find the date, and all within the same application.
I like that a lot because it sort of forces the user to take an image and get more information before contacting support or other people for help, which is, something that's always difficult to do for like a technical support or people who are, working on problems like that.
We are very visual, right? As people, we are images tell us a lot more than a written text and an explanation, right? And I think enabling the usage of a camera where you can actually figure out, because the beauty of it, you point in a general area and it will detect all the little buttons that you might have not even thought about checking what it was.
Well, so now that everybody's seen a demo of Audi Reader, I want to talk about the development process for creating the computer vision models that are helping to power this tool. Um, you shared a video with me also. I'm going to flip over to that in a minute, but I was hoping that you could tell us a little bit about the scale, I would say, of the challenge that you were dealing with. And I'm going to take a look at this video too. Can you kind of let us know what we're seeing here and just kind of the scale of the problem?
When we looked at the beginning, we thought, okay, well, let's do a simple proof of concept. And we began going through the manual, began going through the different lights and buttons. We soon discovered that every model has got something different, functionalities you never heard of, things that you don't really imagine. You think, who's gonna use it? But it exists, and it's there. So soon those 20, 30 functions became 90, 100, 150, 200, and we are over 200 of functionalities. And this is just a list of some of them. And we looked at the 27 models, is 27 models of cars, because we had to we have to kind of limit the amount of vehicles we could cover, because they are so many and they are so different one another. Because each, as you imagine, everything has an evolution, even dashboard lights. Some stay the same forever, but there's so many that have come up and they've changed and they've added new ways. So the usual one example is the little icon for fuel, for gas. That one suddenly has a plug point, but another model doesn't have the little pump with a plug. It has a battery, because it's like we are over gas now, we're over petrol. Now we are looking at just the battery, and then you have batteries with arrows going in, going out, and you start going, wow, I have no idea how we start with this, because every time you look through a new model, you had way more information. So that was the first thing. And next was we need a data set. We need to build a data set. So first we began with a small data set because we needed a proof of concept. It's actually easy, even feasible. And I don't know if I can go over the side of so here where the RoboFlow universe came really, really handy, because there's so many people that have taken photos of their car, apparently. So many people that have done data sets of the interior of their cars, of the dashboard lights. So that one was a first port. The beginning of the proof of concept is let's borrow the universe to actually see if we can train. So we started with only, I think, 5 or so symbols, and that's easy, and then they work fine. But because of Audi and some of the icons are very unique, we needed to train this model, and we didn't have a data set. So that meant we needed to take photos. So we went off and took photos. We had people taking photos from all over the place to try and help us feed, and hence the thousands of images that we used to finally train this model.
I want to return to what you talked about with building a prototype a little bit later on. I love that topic. But for now, you sort of started talking about collecting data and then training a model. I wanted to take a couple steps back and then first ask you a question like, when did you first know that computer vision was going to play a significant role in this project? I'm always kind of interested in this like kind of like chicken and egg idea of like was it computer vision and you're looking for that, or was the problem there that
Early,
you found
I mean,
computer vision? Yeah.
because at the beginning, it wasn't computer vision. At the beginning, we thought, well, hook it up with an LLM and that's it, right? As a lot of people would do. They would go and say, well, I'm using GPT API and ask them to do it. But the problem is they object detection is not as good if you have a quite a wide area. So, and also it doesn't really know some of the symbols. So it starts hallucinating, and the last thing you want is a software that tells you, of course, go and drive with no trouble while while your brakes stop working. So here we needed something robust, something that would give us a very high percentage of positives. So we couldn't afford false positives, and therefore computer vision made sense.
Once you got the idea to use like a visual model, computer vision, did you know right away that you would need to make a custom computer vision model, or did you experiment with any like pre-trained models ahead of time?
I it Well, I remember when YOLO came out, and there was my beginning experimentation with computer vision models. And I thought, wow, this is amazing, super fast, and it can do detection on videos. And I haven't done custom training before for this because some of the models already come with a lot of knowledge. So this was my beginning. I tested some of the computer vision platforms for another projects before. It was just for recipes and understanding what type of food was on the table. But usually those came pre-trained already, so I didn't have to do that much. So I didn't know what was coming my way.
Nice. All right. For our viewers' sake, I was wondering if you could kind of tell me what we're looking at on the screen right now. This is, I think, from your training data set, but I'd love to hear a little bit more about what we're looking at.
These are it's part of the classification model. So what we've done is, I'll go on the technicality later, but these are all of the, well, not all, some of the pictures of the icons of the dashboard lights, for example, of the car. And I think some of them are buttons, like I can see the fourth row. From the left is the third column, so it's a limiter And that's for example a button. I know it because I've spent so many days days and training the model, and the model is amazing. Once you get it, it's so good at picking up those nuances and differences. But these are pretty much a very small portion of all of the symbols that we use to train the custom model.
Yeah, so you mentioned getting into a little bit more of the
Yeah.
technical aspects of how this is working. But so before we dive into this, for our viewers, just a heads up that what we're looking at is a tool within RoboFlow, which is called Workflows. And Workflows is an application that you can use to essentially create computer vision powered applications, or kind of create your own computer vision API where you have an input, like a visual input, and then you have all of these different building blocks. The building blocks might be computer vision models, that might be logic, it might be certain processes like crop or blur, or check when something is inside a zone, things like that. And what we're looking at is a video that Lorenzo, you shared with me. And for my part, I see that we have one object detection model as one of the blocks, and then a dynamic crop, and then we have a classification model. And then I see in this video you were testing out this workflow. Could you let us know, what are we looking at here? How does this workflow work, for lack of a better term?
Yeah. So what we found on performance was dividing the detection into stages worked a lot better performance-wise. So what we did is create a detection model that is trained on every single symbol, button, dashboard lights, to simply detect them. Once it detects them, cuts them out, and then goes to a second model that takes every single cut out and passes it through a classification model. So those little squares, the classification model is a lot better at recognizing what they're looking at, because finding those tiny lights in the big image for the object detection model with so many classes was a challenge, because we were looking at almost 200 different classes, and it's a lot of them in one go. So doing these two passes, and again, this is so quick. Like doing the running the workflow is milliseconds. We are talking at I think between the detection and the classification, we have about 200 milliseconds, 300 milliseconds. So that's it's a very, very fast approach on detection model. And we're not running a video, so we're absolutely fine with delay. I'd rather have a much better detection than fast speed. So that's it. I think this part of dividing the two was really a game changer, because on the first time we did it with so many classes, it struggled to detect everything.
Nice. I love it. Yeah. Performance means different things to different people. It might be speed, it might be accuracy. Um, but, to get better performance, better accuracy, a lot of times it makes sense to split the process up into multiple stages, multiple models, because I guess we could say, like, at the intersection of those models, we get like a much more accurate result, where if one model has to look at a whole bunch of different buttons and then recognize them, it might struggle, like you said. But if we can detect them and then kind of chop them up and then do a second classification, then you're going to get better results as well.
Yeah, and yeah, we haven't. So the future would be to expand it, and because the models have been, at the moment we have one model, classification model, but actually they are divided in different areas depending on what area we're looking at the car. So this is future proofing in a way the application as well, so that if we want to then concentrate and have a switch where we recognize the area, and then based on the area we use the right model for classification, it would make the performance even better.
All right, nice. A little bit of little bit of homework for you here
Uh,
after the session, maybe. Um, I want to switch gears a little bit. And actually, I want to sort of go back a little bit earlier in the process of creating these custom vision models. And let's talk a little bit about collecting the sample images for training your models. You shared a few photos with me, and I'm not sure that this is gonna really come across on Zoom very clearly, but we have some images that were captured with a nice DSLR. Contrast looks great, sharpness looks great.
so crisp, so crisp.
Yeah, it looks wonderful. And then over on
Green.
the right, yep, we have smartphones and contrast isn't great, and there's like a little bit of like bleeding over of stuff. So
Yeah.
tell me what we're looking at here, and tell me about your experience collecting training data and then testing it out, and then using data from different devices.
So this has been a learning opportunity for us, because initially we thought, okay, let's go with a best resolution, because you think, well, more resolution is better than less resolution, right? But it's logic, but it doesn't, for not for the model, because the model is expecting the pictures to come with a certain quality. So we began with the DSLR to do, because we created few versions of the model, and we added more pictures as we went along. But the first step has been this DSLR, going around the car and taking pictures of every single icon, different lighting, different angles. But as you said, the quality was very different than when using a mobile. So the detection wasn't as high. So then we did another pass where we had everybody, like lots of people from the office, going, and everybody was taking pictures, and we collected them all. And we used different phone models, different resolutions, different lighting, because sometimes we're in the garage, sometimes we had the light on, sometimes the lights were off, or we were outside. And then we took yet more images. We had thousands, so many. We had at one point, we're like, where did we put all of this? Like we are going around, everybody with their phone, thinking we can't lose these thousands of images. We had to put them on hard drives, and how do we pass them from one to another? But the reason of the smartphone was mainly is keep as close your training data images, keep them as close as your actual real life images, because it will make the model a lot more accurate.
I love it. You touched on so many like important things. The first being when you're training a custom vision model, you want your training data to be close to the production data that it will be working on later, right? So if you need an app that is going to get imagery from a smartphone, yeah, actually it probably makes sense to train the model on smartphone cameras. That's great. And I also really love that you said I think another key kind of point is like diverse data, like getting a diverse data set. So I like that you mentioned having different people using different
Yeah.
phone models. Can you do you remember like how many different models you had, stuff like that? How many different phones you were using?
I think we had a few different iPhones as well as Androids. So I can't remember how many of us, but there were a few. I imagined we had a 50-50 split between Android and iPhones. But I think they also the change of environment, because at the end you have to think about your end user. If your end user is going to be in their garage with very dim light, so that those are the instances. Um, and one thing that I found RoboFlow amazing was the augmentation, because that is a lifesaver. Because if we had, for example, we had a few thousands images, but with augmentation we can have 3,000, because it adds automatically noise, blur, and that is so good, because you don't have to do it manually. There's no, so you can expand your data set quickly, and really it just helps your model to be more accurate. Thank you.
Nice. Yeah.
Whoever built that one, thank you so much because that saved so much time.
I was about to ask you like a really self-serving question, being from RoboFlow, which was, I appreciate you saying augmentations to expand the data set were helpful. I was kind of hoping to get a little bit of like, you know, what's your background in computer vision, creating custom models, and then I was a little bit curious sort of about like how you ended up training and using RoboFlow, and then any kind of thoughts you had about that.
So my experience in computer vision is very, very little. As I said, I've only used some in the past, but without custom trained models. So and that was all a new avenue of training models. And so I found RoboFlow easy because it had so many tools that makes it fast. The labeling and the creating the data set. I think it's by far has been one of the quickest to learn. So that is, I mean, I'm doing some good review of the platform. Actually, it's been very, very good, very easy to access because I've used other platforms that were so difficult at the beginning because there's no documentation and you're supposed to be an engineer that has so much experience to know all of the different details. So here with a YouTube and videos and self-explanatory guides, that helped a lot of the development of especially the first proof of concept. But yeah, my experience with computer vision is very limited.
All right, so this is kind of one of our last big topics, but you had earlier mentioned about prototyping and kind of browsing on Universe to see some existing data sets and to kind of create a quick kind of prototype. I think I have a question that's along those lines that's kind of related to this. I like to say to people that when you're implementing a new technology or you're building something new, the success often depends more on the people involved in the process than perhaps the actual technology itself. You know, creating excitement and creating buy-in from your colleagues who are going to be working on this project as well. So, for people that are embarking on like a journey to create an app like this and develop their own custom AI. Do you have any tips or any experience about that kind of process of, going from idea to prototype and getting other people on board with your project?
Yeah, I mean, I come from a creative advertising agency, so this is about half of the struggle. Often you have an idea that is a very cool idea, but sometimes it can be far-fetched that people don't believe it. But when you put a proof of concept in front of somebody, you can see the face lit up and go, I would have thought this would be so futuristic as a concept. But as soon as people and try it and you can see there's actually the things that it's viable, it can be done. It helps a lot. Also, it helps you as the person behind to actually understand the problems, the issues that you're going to find. When you build proof of concept, you build small and you build fast. You want to get. I always use the RAT methodology, the riskiest assumption testing. It's just you do that thing that is the most difficult one. If you can prove that one, then everything else is plain sailing. So here, creating proof of concepts is ideal.
Beautiful. All right, I'm gonna use the rat method going forward. All right, so before we kind of wrap up a couple other things and then move on to some questions, Lorenzo, I was wondering, do you have any sort of like projects or any announcements or anything that the audience should be aware of?
Well, I would say for projects in computer vision is get out there, try it, and build because there's so many tools, so many things that in the learning process is so great of putting, testing things out. And often it's a lot easier than it feels. And you can achieve things very quickly. We in agency here, we do a lot of experiences, and we work on experiences. In the end, is customer experience is the section I work mainly. So if there's, if anybody needs help with solving solving problems for the industry, for their clients, then very happy to help and hear what challenge you have in mind.
Beautiful. All right. Well, thank you so much for sharing your experience so far. This has been really fun, and really actually enlightening for me as well. Before we kind of move on to our next section, I did prepare a little game that I wanted to play. Jackson, we still have you here with us, right?
I'm here.
All right. So what we have here is we have that screenshot from the training data set that Lorenzo and his team worked on. This is just this kind of small sample of that training data set, but I wanted to play a little game here where I'm going to call it Do You Know That Indicator or Button? And I guess the way this is going to work is, Jackson, I'm going to show you one of these indicators, and you're going to see if you can recognize it. And then Lorenzo, I expect, should be able to recognize all of these buttons with or without.
Actually, some of them are kind of remember.
Maybe if you have the Audi Reader app with you, perhaps you could also open that up and help us check a little bit. But all right, so to get started, Jackson, what is this symbol?
It's low tire pressure. That's my guess.
Yeah.
Lorenzo? All right.
Yeah.
Okay, that's correct. All right. How about this one, my friend?
Someone somewhere is not buckled.
Yeah, this is the driver. There is no buckle.
Oh, dang it.
We'll give you half a point for that one.
Okay.
Actually, that's amazing. How do you know that is the? Oh, is it because is there like a little steering wheel in that?
It's no, it's slightly different because the passengers has a slightly different icon for.
Oh, all right. So we're learning something new. It also kind of
I
illustrated.
must spend way too much time on this.
No, I like it. I'm sure the model at this point, I hope that it can also recognize those small differences. Um, all right, Jackson, one more. There's like a foot and an up arrow.
This is going to be lighten up. You've got lead foot.
Go slower.
Yes.
So this one is one of those that I have to look up. It's apparently it's part of efficiency. So Audi has got an efficiency clever engine that makes your car more efficient. It just simply says to lift up the foot from the accelerator to improve your efficiency.
All right. I've learned something new, and maybe we're doing a little bit of advertising for the cool features in Audi vehicles as well. All right. Well, I think this is my last one. We have a car and an exclamation point.
Oh my God.
To me, I'm gonna say this is your car is feeling a little surprised, or maybe your car is feeling a little scared, and you need to maybe calm it down somehow. What do you think?
Is this for me or for Lorenzo?
Yeah. Last one for Jack.
I would say this is a potential overhead laser beam. Watch out.
Almost there. No, apparently this is a driver system malfunction. But it's true though. It's impossible, right? You wouldn't know. What do I do when this light comes on?
This is a great example of you have immersed yourself in these indicator lights, but there's actually recently I was talking about with computer vision projects, there's attributes that make computer vision projects successful, and I think one of those attributes is feasibility. Like a lot of times, yeah, a human might be able to do that job, but it's going to be difficult, it's going to be taxing, it's going to be tiring, or it's just going to be like, you can't expect the human to memorize a 1,000-page user manual and maybe retain that information. So I like this example. Let's kind of keep moving on a little bit. Here, I was going to take a little break to just say, if you're watching this recorded somewhere and you want to join a live session in the future, please go over to roboflow.com/webinar. And I think here we might have time for a few questions from the audience. Lorenzo, a couple of people asked, when is this app available? And maybe you could tell us about where it could be used.
So the app has been launched a few months ago, in fact, but it's limited to Spain, because this was a project for Audi Spain. And I really hope that Audi will go and say, this is great, can we please expand it to the rest of the network? Because it was mainly a proof of concept, and it's just an idea for them to solve a problem that we had locally. But I believe it's such a useful tool that I would love to open it up to everyone. So at the moment, it's only limited to Audi owners that have the app, the My Audi and Me app in Spain.
All right. So for the Audi drivers who watch this session, please contact Audi and let them know that you want Audi Reader in your country as well, if you don't happen to be in Spain. I'm going to grab one more question here, and this actually came pretty early on in the session when we were first doing the demo. And they asked, is the vision model using OCR, optical character recognition? And I think, as we saw throughout the presentation, I think the current, we're using like a custom object detection and then classification model. But Lorenzo, this is sort of like, we already talked about this a bit, but did you explore, OCR models that would be able to read text? It might not really have been part of the scope or even feasible.
In our case, it wasn't, because of most of the buttons and dashboard lights being symbols. Very few have got text, so we didn't integrate any OCR, because I think the text is limited, because the scope at the beginning was a certain amount of lights and buttons, the one that were more common between models. But then slowly scope creep happens, and then more and more things get added. So I don't know. This is, again, we are talking of version 1 of Audi Reader. If and when it expands, then we'll see how if we have a large amount of text that needs to be detected, then of course OCR would make sense.
All right, beautiful. I am looking forward to future versions of the application, and let's wrap things up there today. Thank you very much to the audience who tuned in today and asked us some questions. I saw there was a couple that we didn't get to, so hopefully we could follow up on those. If you're interested in working on a project like this, feel free to reach out to Ogilvy Spain or over to us at RoboFlow. Again, thank you so much for joining today, Lorenzo. It was really fun having you, and I really appreciate the time that you took to share your cool Audi Reader vision-powered application with us and everything that you learned along the way.
Well, thank you so much for having me. It's been a pleasure, and I hope everybody enjoyed the session.